elements that are not part of the CDA schema. And we can also reference external objects like images inside XML entries here. The image is wrapped in a tag observation media. The threat to confidentiality of information is caused by this threat, which is caused by misuse of privileges by authorized users, is known as insider threat. And the level of misuse is classified as these three categories. The first category is carelessness or unintentional misuse. This occurs when user forget to log off properly or by mistake open the records of some other patient. This threat becomes more profound if you consider the scenario where sensitive data of patients is available to all users in a healthcare facility. The second one is curiosity. It is assumed that users, in a healthcare setting, it is assumed that a user will access health records of patients under their care only. The audit mechanisms are usually in place to record any such access, but still users, due to curiosity, might snoop in medical records of ex-relations, celebrities, or colleagues. And the third is malintentions. The authorized users might access personal information of any patient to harm or embarrass him, or just for profit to sell this information. Also, there is a possibility that this information may be used by employer to deny employment or to deny benefits to a patient whose privacy has been compromised. So, if the patient cannot trust the healthcare provider, then they may resort to extreme circumstances like giving inaccurate information, paying out of pocket, changing doctors, or avoiding treatment at all, just to protect their information. Context is any information that can be used to characterize the situation of an entity. An entity is a person, place, object that is considered relevant to the interaction between a user and an application. A system, process, or model that is context aware if it takes decisions according to the context parameters. The well-known context parameters are identity, time, location, activity. Now I'll explain the related work and the different access control mechanisms, including policy machine. First is role-based access control. RBAC has emerged as a standard for specifying permissions for a large group of users. It allows defining roles similar to the functional responsibilities of users in an organization setup, and then permissions are given to the roles. RBAC policy consists of users, the roles the users can assume, objects, operations, and permissions available to each role. A user can activate roles assigned to him in a session. If a user activates any role, then he gets all the permissions associated with that role. Discretionary access control, DAC, is an access control mechanism that allows users to own objects or files, and they can give permissions to other users for objects under their control. A strict DAC policy requires that the owner is the only one who can grant access to an object, and ownership cannot be transferred. Whereas a liberal DAC policy assumes that the ownership can be transferred to other users based on a single level grant or a multi-level grant. The single level grant means that he can just the ownership can go only one step ahead. Generalized temporal RBAC defines temporal constraints for RBAC using periodicity and duration constraints. The temporal constraint can be defined for operations of role enabling, role assignment, and permission assignment. XML-based generalized temporal RBAC, which is XGT RBAC, it proposes XML-based policy specification language for GT RBAC. Here, XML schema is used to define user to role permission assignment, and separation of duty and temporal constraints. The policy is defined in XML sheets, which are processed by XML parser, and then the policy information is enforced by the GT RBAC processor. Most of the scheme proposed for healthcare in recent literature, like XGT RBAC, XFederate, and others, extend RBAC to formulate privacy and security policies. But protection of private information using RBAC alone is not enough, as sensitive information should be available to the primary doctor only. Whereas an RBAC, if a doctor role is available to a user, then he can access information of all the patients, including sensitive information. Hippocratic databases have been developed for protection of personal information. The basic theme is that data collection and disclosure should be associated with purpose specification and user consent. These databases are designed to enforce better disclosure policies so that patient preference is taken into account. They also have an audit mechanisms to find security breaches, but in case of insider threat, the goal should be to protect the information in first place instead of finding the culprit after the damage has been done. XSCML is a policy specification language which allows access control policy formulation in XML. XSCML profile of core and hierarchical RBAC have been developed, but it still lacks separation of duty constraints of RBAC. Also, temporal constraints like access during 9 to 5 a.m. or for a duration of 5 hours can be expressed in XSCML, but it is not as expressive as like the temporal constraints in GDRBAC, which allows to specify periodicity constraints and also constraints like 9 a.m. to 5 p.m. for Monday to Friday only. The principle of least privilege is one of the basic principles of information security, and it requires that a user be given no more privilege than necessary to perform a job. To apply the principle of least privilege, the system needs to identify the first job is to identify the job of the user, then determine the minimum permission set to perform that job, and to restrict the user with those permissions only. Now I'll explain policy machine. Policy machine has been developed by National Institute of Standards and Technology (NIST), and it provides the ability to configure and enforce arbitrary attribute-based policies. It can enforce policies like RBAC, DAC, mandatory access control MAC, and also combination of multiple policies. It helps to protect objects under one or more policies while enforcing these policies through a series of PM functions that are executed in response to user access requests. The basic elements in policy machine are users, which are users of the system, operations like read, write, delete, and create, objects objects may refer to files, processes, or system resources, user attributes, policy-specific attributes of users like a doctor in case of RBAC or secret in case of MLS, and object attributes, which are policy-specific attributes of objects. Then there is a reference mediation function which evaluates the user request and grants a permission only if it is part of the permission set. And then there are subject attribute constraints. This is a list of disjoint user attribute set. If a user has been assigned a user attribute from one user attribute set like doctor and intern, then he cannot be assigned the user attribute from the other set, which is consultant in this example. Now I'll explain how permissions are mapped to users in policy machine. These are the assignment relations for like user to user attribute assignment means that user U has the after the assignment user U has the attributes user U belongs to the users of user attribute UA. And when this assignment has been done, then user has the capabilities of the user attribute. The set of capabilities operation O for a user attribute is derived from assignments between operation sets and object attributes is denoted by capabilities of the user attribute. We get the capabilities by assignment between user attributes and operation sets, and we get the access control entries for an object by assignments between operation sets and object attributes. These two concepts like capabilities and access control entries will be clear when I show you the next slide, which in context of our access control matrix. Just to clarify the capabilities and access control entries, here like doctor, intern, and consultant are the user attributes, and O1, O2, O3 are the object attributes. The capabilities of doctor are that he can write O1 and write O2, while the access control entries for an object O1 will be that the doctor can read, write O1, and the doctor can, intern can read object O1. So this is how with the assignments of, we can generate capabilities and access control entries by assignments of user attributes and operation sets. Uh, this slide shows the architecture of the reference implementation of policy machine. Policy machine is 3-layer application consisting of presentation layer, application logic layer, and data layer. The data layer uses Microsoft Active Directory as a data repository and LDAP server as access mechanism. The application logic layer contains policy server, which manages all data and relations stored in Active Directory. And the policy server provides services to admin client and session simulator. The admin client, session simulator, session manager, user sessions, and applications are all part of the presentation layer. The policy to be implemented is specified in a PM file, which is loaded into Active Directory by the admin client. The admin client reads the policy specification and sends them to the policy server as commands, and the policy server, after parsing the commands, loads attribute and permissions into Active Directory. The virtual object computation allows finding the objects accessible to a user attribute, and during subject attribute activation, the attributes are activated for the user according to the capability. And finally, reference mediation function grants permission if it is available in the capability set. This slide shows that a typical implementation of RBAC using policy machine. This is an RBAC policy in PM policy machine where like doctor, intern, consultant are user attributes, and medical record and development are object attributes. And we can these are the assignment relations. The arrows are the assignment relations, and the user can be assigned this user attribute doctor, and further this user attribute is assigned permissions by assignment onto operation sets. When this assignment has been carried out, then doctor can read this object attribute, which has been further assigned to object O1 and O2. So this is our implementation of RBAC, and here the reference mediation function falls here, which checks that if before giving any permission that these are part of the capabilities of a user or not. This slide shows the policy syntax for an RBAC policy. How this is a typical RBAC policy is specified in a PM file, and we are telling that add a policy RBAC into PM and add a user attribute doctor to this policy RBAC. Each command takes a single line and may start with add or assign. Assignment relations, here we assign the object attribute to an offset, and here different permissions are being added into an offset. Event response language is context-free grammar based on EBNF format. PM uses event response rules to take specific actions in response to certain events, which also helps to enforce history-based policies. A script in our language starts with script header and may have 0 or more rules. A rule consists of 2 parts: event pattern, which starts with when, and a response to that event starting with the keyword do. The script is compiled and enabled by the policy server, and it tries to match which events which are occurring with the event pattern. And if the event matches, then the policy server takes the action specified in the response. In the example script shown, the event pattern starts after when, and this event will be activated when any doctor reads an object of attribute forms. Then it will assign that object attribute to the object attribute shared. Now I'll explain the implementation of generalized temporal RBAC in policy machine and how policy machine can be used to mitigate insider threat in healthcare domain. These are the new capabilities we have added into policy machine, like specifying command syntax for temporal constraints, extending of Active Directory schema for temporal context, and then context validation for in the policy server before assignment of user to user attribute or user attribute to permission set. It is checked against the temporal constraints, and then calendar specification has been added into event response. Even in event pattern, we try to match initiate an event if the current time matches to some specified time, and then we have added a healthcare application for checking of constraints. These are the details of the GTR back policy in policy machine. Interval is defined by start time and end time. An interval constraint is valid if the current time falls between the start and time and the end time. If the end time is not specified, then interval is valid for all times after start time. Periodic time constraints. It defines the start time at which an event occurs periodically. The start time is defined in terms of year, month, week, day, hour, or minute. The duration constraint defines the unit of time and number of units the constraint is valid after start time. And these temporal constraints are all three: interval, periodic time, and duration are valid for user attribute activation, user to user attribute assignment, and user attribute to permission assignment. Also, the context validation has in policy server like user to user attribute assignment and user attribute activation is done during subject attribute activation, and before activation or assignment is done in the policy server, we check against temporal constraints that the temporal constraints are met or not. If the temporal constraints are met, then only then the assignment is done. And similarly, in the reference mediation function where permission is assigned to the user, again temporal constraints are checked for validity. The syntax for the temporal constraints is shown in this slide. This is how we specify the constraints in the policy file. This is the name of the constraint, like first quarter, the begin date, which is like month, day, year, hour, or minute, and the end date. And then this constraint is valid of which relation, that this is for user to offset assignment or user to user attribute activation. And this is how the constraints are, the interval constraint is specified. So coming on to periodic time constraint, here we give the name, and then if it is valid for all years, the months, maybe for the first quarter only, the first 4 months, and then the weeks, or just the first week or all weeks, then the days, if only working days, then these are the days for the periodic time constraint, and what time this constraint starts, and in the end, for the relation which this constraint is valid. And this is the duration constraint, and after the start time of periodic constraint, how much duration that constraint is valid. And this is like, if we have, in the previous slide I have given the periodic time constraints, and this duration constraint here tells that the constraint is valid for 8 hours after the start time of periodic time constraint. And the same we have like for the relation, for which relation this constraint is valid. So to store the constraints, these interval, periodic time, and duration, we have also added classes into Active Directory schema. So whenever the constraints are read from the policy file, these are stored into required places in Active Directory. So these are the classes, and these are the attributes for interval, periodic time, and duration constraints in Active Directory schema. The calendar specification has been added to event pattern, which allows to take time-sensitive action. The event in calendar specification is activated when current time matches the time which is specified in the script. The script is compiled. In this case, script is compiled and enabled in pod server. All actions coming under the calendar specification are scheduled to execute at the future time. And if that time has already elapsed, then the actions are performed immediately. This is the grammar for the calendar specification. So coming to mitigation of insider threat, for mitigation of insider threat, the healthcare data must be classified as normal or sensitive. And sensitive medical data should be the one disclosure of which will cause embarrassment or discrimination to the patient. The patient's privacy is compromised by leakage of sensitive information, so he or she should be the one to make the decision to declare the information as sensitive. This can be achieved by applying RBAC for normal documents and DAC policy for sensitive documents. And in this case, the curious insider is just now restricted to the normal documents, as the sensitive information is available to the patients for his is available to the doctor for his own patients only. Just to further clarify, I'll just give a hypothetical scenario. Like we have, for example, we can implement all the cases only in DAC policy or only in RBAC policy, but they have their own issues if you try to implement these requirements in a DAC policy. Here I'm just taking a hypothetical scenario that we have 2 doctors, Alice and Bob, and 4 patients, A, B, C, D. And each patient has some sensitive documents. So the use of DAC policy as authorization mechanism will require that, in this case, that Alice has access to all the normal records for all the patients, and then she can access the sensitive documents of patient under her care. But this scheme requires constant updating of access control lists as new CDA documents are created or new patients are added. And this approach will not be scalable if you consider a large volume of CDA nodes. For example, in one of the, so it was like in Mayo Clinic in 2005, they were like generating 50,000 CDA nodes per week. So for a large volume of nodes, updating DAC is not scalable. Using RBAC, both here we have like we can group all the normal documents, and if the role doctor is assigned, any doctor can see all the normal records of all the patients. But each patient will need a unique role to access his own medical records. For example, this D patient A, and the patient can be given this role to access his documents. The sensitive information for patient is now available under the same role, and primary doctor can access this information using this role. But still there are issues with like consultation, that this role cannot be shared between 2 doctors. If a role is given to a doctor, then he may have the permission for all the sensitive documents, whereas a patient will just like to give permission on one document among his all sensitive documents. So this is just to like we have the DAC gives the benefit of discretionary access, whereas RBAC has the benefit of being scalable, and we can add the context information. So we propose like using policy machine, we can have like move the sensitive information both DAC and RBAC policies, and keep the normal records in RBAC. And now if a user tries to access sensitive information, he has to meet both the RBAC and DAC policies. Only then he is allowed to access this sensitive information. This has some show you that this is how we are implementing these policy this hypothetical scenario in policy machine. Now in RBAC, the Alice has information for all the documents, and in DAC she's given a permission for sensitive documents for her own patients only. During reference mediation, she has permission for she will not be given permission for C and D, because these documents are also in DAC policy here, and she has not permission for these documents in DAC policy. So a user is given permission for an object only if he has permission in all the policies. If an object is in 2 policies, the user has to have permission in both the policies, DAC and RBAC in this case. So here access of users to health records is controlled by policy machine. Different type of clinical data can have different security requirements, and multiple policies can be enforced on a single document according to the requirement. A user request to access any clinical document is evaluated by policy machine by checking the status of a user under a policy, and available permissions to clinical documents are assigned to the user. The multimedia objects which are part of a clinical document may have different permissions. For example, a doctor may be able to see a radiology note under RBAC, but not this X-ray image, which might be declared sensitive by the patient and is under DAC policy. So, and the image is only available to the surgeon who is treating the patient. So we can apply different permission for objects embedded in the clinical documents. This is the architecture with the new modifications. All the clinical documents and the related multimedia content is stored in the policy server. The user is logged into session manager after authentication. The session simulator communicates with policy server, and after visual object system computation and subject attribute activation, the relevant objects are displayed to the user under applicable policies. The objects visible to a user in user session can be accessed using CD application developed for policy machine. The healthcare records based on CD are in XML format, and the CD application is launched whenever an XML object is accessed. The application reads the XML object and displays the clinical data and the associated multimedia content to the user. The multimedia content is only displayed by the CD application if the user has permission to access them under some policy. Here we just give some hypothetical requirements for a policy. Any person in role doctor can see normal records of all patients, but sensitive records are available for access to the doctor for his own patients only. All patients have access to their own medical records. The role doctor can be active only during working days, that is Monday to Friday from 9 a.m. to 5 p.m. And a doctor may allow access to a colleague to have consultation on some record for his own patients only. And using policy machine, this is the scenario how using different assignments in different policies we can achieve these requirements. Like here, the user Bob is assigned the role. Is assigned the role doctor and has under policy GTR back. He can access all the normal records for a patient, but the sensitive records are available in DAG policy. So, as he doesn't have the permission for sensitive records, so he cannot access sensitive records under the role doctor. And now a patient can access all her sensitive records and the normal records. Here I am assuming that X-ray image and history note are among the sensitive documents, and these are the normal documents. And the LS is the doctor who is treating the patient Katie. Now she can access the normal records when she is given the attribute doctor, and the sensitive records under DAG policy. She also has been assigned the sensitive records, and she can excuse me. Now she can give permission for a consultation note under DAG policy to another doctor, Dr. Charlie, who can only access normal records and the record which was allowed, which LS allowed for consultation to Charlie under DAG policy. So this is how we are moving to the, only allowing sensitive documents are protected under DAG policy, and we can have the benefits of scalability and discretionary access by combination of both the policies. This is just a sample of the XML document, how it is displayed in the CD application. So I'll conclude here. Like we need more stringent policies for sensitive data. Access control requirements for healthcare requires that more stringent policies be developed for sensitive data. Temporal constraints for RBAC have been added into policy machine, and based on GTR back and DAC in policy machine, multi-policy framework for mitigating insider threat in healthcare domain has been developed. In future, we are looking at to extend temporal capabilities to other models like MLS or DAG, to develop location-aware capabilities for policy machine, and also to do expressibility analysis and minimal language representation for policy machine. And we're also looking at distributed applications that if like two organizations are using how they can do conflict resolution for their policies among themselves. Maybe I'm a bit early, so I'm open for any questions.
Are there any questions? Did everyone understand everything?
I understand nothing.
Well, maybe we should have a little test on this. I'm sure that you all understand. Well, okay. Let us think our speaker.